Hey everybody, this is Paul. Welcome to part 3 in the Introduction to a Heap Data Structure. So in this tutorial I'm basically going to be showing you how we can translate a tree structure like this, a heap as a tree, into a heap as an array structure. So basically I just went ahead and I did this already, and I'm going to explain to you how I filled in this array. So basically you just start with the root here, and the root is going to go in index 0 of the array. So I've got 20, the root, in index 0, and then to fill in the rest of the array we simply just go down the tree from left to right and fill in the values. So 13 and 9 would come next, 13 and 9 are there, and then 8, 5, 3, and 7, 8, 5, 3, and 7, and then we go down to the bottom row, 6, 2, and 1, 6, 2, and 1. So it's pretty simple to see the relationship between the tree and the array when you look at it that way, but we need a way to be able to let our computer know, our program know, what the relationship is between the parent and the child. So it's really easy to see in this tree structure, but not so easy to see in this array structure. So basically I've written down the algorithms that basically tell us which child belongs to which parent and what children the parents have. So basically if we're looking for the children of a certain parent, n is going to be the index of our array, and if we're looking at some certain index of our array, then it will have children at 2 times that index plus 1, and another child at 2 times the index plus 2. So for example, if we wanted to find the children of our root node here, we would basically look at its corresponding index. So the root has an index of 0, and so we're going to use that index number as our n here. So basically, array index 0 will have children at 2 times 0 plus 1 and 2 times 0 plus 2. So 2 times 0 plus 1 is 1, 2 times 0 plus 2 is 2. So we end up with a 1 and a 2, which tell us which indexes hold the children. So 1 and 2 are the indexes, and they hold the children 13 and 9. So 20 is the parent of 13 and 9, just like we see in our tree here. So if we were to try to figure out what the children of the number 9 is, 9 is held in index 2, so we use that index number as our n. So 2 times 2, which is our index number, 2 times 2 is 4, plus 1 is 5. So index 2 has a child in index 5. 9 has a child of 3, and there it is on our tree. So if we look at the other child here, 2 times 2, the index that we're looking at is 2. 2 times 2 is 4, plus 2 is 6. So index 2 has a child in index 6. So index 2 holds 9, index 6 holds 7, 9 has a child of 7, and we can see that in our tree as well. So we can use this all the way down the tree, and then this relationship right here basically tells us if we have some child index, where is its parent located? So the parent of a child is going to be located at the child's index minus 1 divided by 2, and then we take the floor of that. So this is just a mathematical notation called the floor, and it basically means that if we have some number, say like 3.5 for example, we just round it down. So that's really what the floor means, is we're just going to round this number down to the nearest integer. So for example, if we were looking at index 7, well, 7 holds the value 6, so in our tree we're looking at this part right here, and we want to figure out who is the parent of index 7. So plugging in the index 7 here, 7 minus 1 is going to be 6, 6 divided by 2 is 3, and so then we basically say, okay, we used index 7, we got index 3 as our outcome. That means that 6 is the child of 8, and we can see that in our tree here. And we can also look at, if we wanted to, this one right here, 2 is located in index 8, and so we plug our index 8 in here. 8 minus 1 is going to be 7. 7 divided by 2 is 3.5. We take the floor of that number, which becomes 3. We ended up with 3 as our result when we plugged in the value 8. So index 8 is the child of whatever is in index 3, or the value in index 8 is the child of the value in index 3. So 2 is the child of 8, just like we see in our graph here. So anyway, that's basically how you can describe a heap as an array, and basically how you translate between the tree and the array, and the relationship between the child and the parent once they're in their array elements. So anyway, thank you guys for watching. Have an excellent day, and if you haven't already, don't forget to subscribe.